Well, good evening, everybody. This is Chris, KY4CKP for Lake Cumberland Amateur Radio Association. This is our hands-on with LCARA, presenting, featuring Callum McCormick of DX Commander fame, uh, creator of antennas and enjoyable YouTube videos for many years now. And we're really excited that he's taken the time to present for us this evening. And so he'll be presenting, and then we'll have a question and answer session following. So I know we've got a few folks there in the room and a good crowd building up here on the Zoom session. So with that, Callum, if you're ready, we can hand it over to you.
Good evening, everybody. Hello. Yes, it's Callum here from DX Commander. Well, thanks for having me on board. Notice there's a few folks here on the screen. Just for my records then, Chris, what is the actual club name? Say that again.
Lake Cumberland Amateur Radio Association.
Yeah, okay, fine. Well, welcome, guys. So Chris got in contact with me, off my YouTube channel, and he said you fancy doing a talk one night, and of course I've got the time difference, but Saturday night at 10:30 my side works very well because I've normally had a couple of drinks, something to eat. We've just watched Ant-Man on the telly, and I don't know what the rest of the family are doing, but it's time for my fun and games here, producing some content for you and for my YouTube channel, who knows. So if you get a piece of paper and a notepad handy, because there's bound to be a little question you've got that I might not know the answer to, but as a team, we can have a chat about it, can't we, afterwards? Because what I want to do is, I get a lot of, okay, start again. There's 32,000 subscribers on my channel, which isn't big for the internet, but it's big for me. And because of that, people sometimes think that I know everything, and I don't. But one of the questions I often get asked is, what is the best antenna, right? So they'll say, I've got antenna A. Would your antenna, a DX Commander, be better? Now, the thing is, I actually don't believe, there's a place sometimes in the world for every antenna. So let's just compare two. Let's compare a dipole for, let's say, 40 meters and a ground-mounted vertical. Let's keep the thing really simple, because each one has got a benefit over the other. So for many years, I only had 40 meters in my backyard here. And in England, we call that the garden. In America, garden is where you probably grow your potatoes and whatever. But anyway, our backyard. I had actually a simple, was a dipole for a while and then a loop. But 40 meters was nice because it's the only band I was kind of competitive on for that 200 to 700 mile hop. So for me in the UK, 200 to 700 miles is, I'm just going to press a button here for my recording. 200 to 700 miles is kind of France, close in, all the way out to nearly the other side of the Mediterranean towards Cyprus. And 40 meters during the day I used to really enjoy because I had a low to the ground dipole or loop, whatever it was, and I'd be quite strong, 500 miles. Now, many years ago, I used to play with a vertical in the backyard as well. And I compared it during the day. And I always felt that the vertical wasn't as good as the dipole. I mean, it took years to kind of work this out. So I immediately discount the vertical. But it was an S point, maybe, something like that. Let's just park that. Let's go to the 10-meter band now. If you're on 10 meters or you started maybe on CB, you might have a vertical, like a 5/8, I don't know, a Gain Master or an IMAX 2000, they call them on CB. And I've got one and I tuned it for the 10-meter band. Now, typically on 10 meters, most of the, there's two camps. There's one guy who wants to talk to his mate 10 miles away, right, literally across the valley. So he doesn't want any height at all on his elevation. He's after 0 degrees. So that's the first one. Then there's the other guy who wants a bit of skip. He likes collecting QSL cards or whatever else. He likes the DX. Now, DX doesn't arrive at 0 degrees. DX arrives at between probably 3 and 8 degrees off the horizon. So, in fact, for him, a ground-mounted vertical might be better. So there's no such thing as what is the best antenna. Now, I wonder if I might take my pullover off. I've got all the lights on me. I just realised I'm warming up, Chris.
Not a problem. Make yourself comfortable.
So this got me thinking about tonight, you know, what we're going to chat about. Oh, I said let's park the 40 metres. So the 40 metre thing. Again, there's no such thing as a best aerial, whether it's a dipole or a loop or a vertical for 40 metres, because it depends what you want from it. If you're just after a 500-mile hop, I think you'll find a fairly low to the ground, 20 foot off the deck dipole will do your 500-mile hop quite adequately. And in fact, your vertical, if you really wanted to compare a vertical to a dipole on 40 metres, then you don't start doing that until it's night time where you've got 1,000-mile plus skip. Then you'll find that the vertical will outperform the dipole. So, it just got me thinking. I mean, it's kind of a straw poll. I wonder if, let's take 3 main antennas that I suggest everybody builds at least once in the first 5 years of their HAMRadio career, because it costs pennies to experiment doing this. Assuming you've got to run a coax from here to your backyard, then and we'll build monobanders, you know, in our mind, and then let's consider how we multiband these things. So the 3 antennas that I built quite early on in my career was a dipole. And I'll just explain how I built it so everybody is on cue and people who are watching this in the future go, well, I don't quite know how to build a dipole. So we'll cover that, all right? We'll do a vertical and then we'll do a loop as well. And then what I want to do is just cover how we multi-band these things, how we get them to work on more than one band. Because I don't know about you, in my HAMRadio career, I used to love being on as many bands as I could at once, all right? Which actually is a bit ridiculous because it takes a good couple of years to understand a band. So a good friend of mine, Tim, M0MCX, he's a 20-metre guy. You know, he knows 20 metres inside out. He has been on 40 metres because he's been around my place and we've done 40 metres. But in the main, he's a 20-metre man, you know. And he knows that inside out. You can't know every band and how it all works and all the quirks. So let's do a dipole. So just in case, I mean, I know all us here on our Zoom call tonight know what a piece of coax looks like, but if you didn't, it looks like a wire, you know, and if you cut it open, you've got this braid around the outside, a shield, and then right in the center of the cable, we've got this little copper wire running down. So it's the sort of stuff you connect to your satellite or your TV installation. That's coax, right? So how does a dipole work? Well, I was talking to my accountant last year. I think. Bit of a strange story, but it forced me to think of something. He wanted to know why a DX commander, and go on, if you don't know what a DX commander is, go on the internet, just do a search and look at images and you'll kind of get a grip. But it's basically got multiple elements on a vertical, and we'll cover that in a bit. Gary wanted to know why I've got all these different lengths of wires. And I said that HAMRadio is a bit like playing a piano, right? So your low frequencies need the longer strings on the piano, and the very high frequencies need the shorter strings. Well, that's the same with us. So if we take the 80-metre band and we go an octave up, you end up at 40 metres. Go up another octave, you end up at 20 metres. It's all actually harmonically related. So our dipole, right, needs to be cut to the right piano string. Okay, there is a formula for that. It's to do with the speed of light and a few other things, but effectively each leg of our dipole is a quarter of the wavelength. So if we've got a wavelength of, let's say, 40 meters, and by the way, the 40 meter band is, depending whereabouts you are, somewhere between about 41 and 42 meters, as it so happens. A quarter of a wavelength is about 10 meters. Now, there's a couple of bits of jiggery-pokery goes on the inside the wire that generally makes it a little bit less long. So let's call it 10 meters. It's actually normally about 9.5-ish, depending on the wire you use. We take these two, and I'm doing this shape, let's call it inverted V, because very often on for a dipole, we might find a little tree somewhere, and we put the coax, bit of paracord, over the tree. We attach the paracord to our coax. The centre of the coax goes down one 10-meter leg. It's for 40 meters. And then we solder or crimp on or something the other leg down the other element. Okay, so we've got these two elements, if you like. And that is all a dipole is. We'll remind me to do chokes in a bit. We'll do the chokes. So if you've never built a dipole, I know it sounds crazy because there are plenty of people who haven't actually built a dipole. But pick a band, 17 meters, whatever else. Find the tallest tree, throw a tennis ball with a bit of string on it or something. Pull it up and just practice your cutting and all the mechanical fun and games you have getting this tuned in. Because just like a piano tuner, our radios, and very often we've got an outboard SWR meter, and that'll tell us when it's in tune. And I'm doing this curve here because we want the lowest voltage standing wave ratio. In other words, we're just trying to tune it. That's our tuning fork, is the SWR meter, getting it in tune. It won't work forever, you see. As we go up in frequency, we start to lose the tune. So it's a particular point. Now, interestingly, as you're tuning this dipole, it's quite easy to chop a bit off the top. And what I do is I intentionally make it a little bit longer with this fold back. Go up, come back down, this little loop at the top. I put my paracord on, you see. There we go. And then I find out it's a bit long. So what I do, because it comes all the way up, and then I've got this loop, is you can chop a bit of the loop off. But interestingly, when you chop a bit of the loop off, it doesn't seem to chop very much off. And that's because we've actually got a bit of linear loading at the top. So what we need to do is make quite a longer loop, because for every 3 feet we chop off or 3 inches, doesn't matter, every 3 feet we chop off the return loop, we're only reducing the size of the whole element by about a foot. That's called linear loading, you see. Just have a drink of milk. And now that works with a vertical, or it works with a dipole, or anything. There's your dipole anyway. And so you can trim these loops, because they'll both be the same size. Oops. And the chances are you probably want to return both of them rather than just one. Okay? Otherwise, in your mind, you'll know that one element is 6 inches longer than the other. And that happened to me once. It annoyed me forever. Didn't have any effect at all on the SWR, I'm sure. So, built my dipole. So that's good. But that'll only work on one band. Okay? Almost. I'll come back to that. We chose 17 meters. We were talking about 40 meters. So if we've built our dipole and we leave it up for a couple of months and we play on it regularly, we really get the hang of how our 17 meter dipole thingy is working. Then I suggest we try a vertical. So a vertical is just like one of the legs, okay, and we're going to turn it upside down. So the centre of our coax goes straight up the tree, and it goes up on the 40 metre band. That would be 10 metres. It's about 33 feet. And then the braid, instead of going back down one side, the braid, we're going to scatter a few what we call radials a bit of copper on the ground, effectively. Now, radials is a massive subject, and if you really want to know about it, then ON4UN did a great chapter. I think it's chapter 11 on the low band DX book, because people talk about elevated radials, and there was a bit of mystique and mythology with elevated radials, which means elevated radials basically means the feed point, this ground mounted, so the coax comes along, goes straight up, and the radials are on the ground, and the whole thing is mounted on the ground. We don't earth the conductor, keep that bit off the ground, you see. But somebody decided it would be a good idea to put this whole thing on a pole and elevate it right up in the air. And instead of having the ground radials on the ground, we'd come down at angles. Well, how many do you need? 2, 4, 8, 16? Actually, it's quite a lot. So you'll get a tune on 2 elements, 2 radials, but I can guarantee it won't be very good. But I thoroughly recommend you read that chapter. It's on the internet somewhere, and I'll try and remember to send the link to that chapter to Chris, actually. But again, our vertical is only going to work on the one band. We'll do harmonics in a minute. But I thoroughly recommend you try that out. So if you're not on 17 meters, for instance, try and give it a go. It's what's the length? 17 meters. I can calculate it. 3 and a bit meters, nearly 4 meters long. 3.85 rings a bell. I'm a metric guy. I'm sorry. I don't know what that is in inches, but I'm sure you can work it out. So now the other one I built in the first couple of years of my career was a loop. Okay, not a magnetic loop, which has got its own science, but something called a full wavelength loop. I built mine for 40 meters. Mine happened to be in a triangle, and I used a couple of bits of timber, actually. They're banister rails for a stair. In the corner of my garden, I had some paracord, a couple of loops, and I just raised this triangle around. And the coax is quite strange. One side, the centre of the coax feeds one side of the loop. It's continuous because it's like a short circuit, because it comes back to the braid. Now, although we've got our tuning fork, all right, there's also something called impedance. And it just so happens that a loop will give us a bit of a high impedance, somewhere, got an itchy nose, somewhere between 150 to 220 ohms, depending on the height above ground, actually. So what normally do is, there's 2 ways of feeding that. You could put a 4-to-1 balun in place there, and that'll transform our 200-ish ohms down to 50. You get a perfect match on your radio. There's another way as well. I'll mention it. This definitely turns it into a monobander, though, is we use a quarter wavelength, less the velocity factor of 75 ohm coax. Connect that to it, and then connect our 50 ohms there. The coax will act as a transformer, and we'll end up at 50 ohms at the back end of the 75 ohm cable. That'll be on the internet somewhere. Let's not dwell on that too much. So I've done the vertical, the dipole, and the loop. Well, let's just talk about harmonics, because what happens is that a dipole resonates. I'm going to we'll stop in a minute, and then I'll just ask Chris, is everything all right? And is he hearing me? And we'll just have a rain check, make sure I'm not, got it all wrong here. But, I'm talking to advanced physicists. I didn't realise that they were all, physics winners. So, multibanding and harmonics. So just before I start, I'll just ask Chris, everything all right your end, Chris?
Sounds good to me so far, Callum.
Are you having fun, everybody? Give me a wave, somebody. There we are. Lovely. So, harmonics are quite interesting. So if you build a 40-meter dipole, you'll find that you'll get a resonance. The tuning fork thing, right? Our SWR will work again, not far off 15 meters, because a dipole naturally resonates every other harmonic. So if we've got a 40-meter band, let's call it 7 megahertz, 7.1, there we are. The next harmonic would be 14.2, but it doesn't resonate there. In fact, it doesn't resonate there at all. It doesn't want to work there, right? Because that becomes, it's just the wrong size, a wrong shape. But at 21.3 megahertz, it will resonate. Now, I have discovered that depending on the wire you use and the height above ground and a few other variables, don't actually sync perfectly with the harmonic. So in fact, it'll resonate about 150 kilohertz above that. So the next time it resonates will be about 21.45. That's because we're now 3 times higher over ground than we were a minute ago on 40 meters, because everything changes, you see. There's a trick to get that tune back in. We'll cover that in a minute. So our 40 meter dipole automatically gives us 40 and 15. Oh, it's quite handy. What about a vertical? Well, a vertical also resonates every other harmonic as well. It's exactly the same as a dipole. So our 40 meter vertical, 30 something feet, our tuning fork will work again at 21 and a something megahertz. Very handy. Although some people say, particularly on QRZ and EHAM, when I first read it, that a 3/4 wave, which is what it is now, it's a 3/4 wave. In fact, we're getting a better match to 50 ohm coax than we were on our quarter wave. This is a 3/4 wave antenna. Now our 15 meter, 21 megahertz. Cut for 40, but now working on 15. So it becomes a 3/4 wave. But in fact, low to the horizon is still 3 dB better than it was as a quarter wave. So it's a fine antenna. So you get 2 bands on that as well. Now, loops are slightly different. Loops will resonate on every harmonic. I don't know why. I'm not a physicist like you guys. But you will get, so if you tune it at, say, 7.1, the next time it'll work would be 14.2, 21.3, and then 28.4. Marvellous. So my little 40 meter loop that I had in my garden was a multiband antenna. And because I didn't have any rotators and no heavy hardware, and it was cheap as chips, as we call it in the UK, French fries chips. It was a great, looking back on it, it's probably the greatest antenna I ever had. It was, if it fell down, it's not going to hurt anybody. I loved it. And when the skip's in, it was fairly low to the ground. It still works, you see. I really liked that aerial. And it was multiband. Easy. Fed it with a 4-to-1 balun, because you've got this impedance. It's not exactly 200 ohms, by the way. It depends height above ground and frequency and a few other things. So, for instance, on the 10 meter band, it's 4 wavelengths all the way around. So it changes. I think there the impedance is a little bit lower. I think it's about 150. I can't remember. So multibanding these things, that's quite good fun. Well, dipole's easy. Many years ago, somebody came up with the idea of going, well, if we've got 2 10-meter legs on our inverted V off our apple tree thing, what happens if we put 2 5-meter legs as well? It's called a fan dipole. And I'm sure many of you might have built one, but there's a lot of people actually have never built one. They just know it works. And they're very comfortable with the idea that it will work. Again, if you don't build it, you'll never come up with all the, I never thought about that. How do you stop the elements all twisting up? There's all sorts of things. I used weights on mine, actually, to keep it down. Actually, there were metal carabiners that on high power flashed through the insulation on the wire and made the antenna on 40 meters that much longer on one side. There we are. That much on 40 meters isn't actually too bad. It's about, I don't know, probably 50 kilohertz. So it doesn't actually change the tune much. It annoyed me, That was high power, though. So fan dipole means that you could run 40 meter legs and 20 meters, right? Let's say 40 meter legs. 2 10s, 20 something feet, 23 feet, whatever 10 meters is. 27 feet, I think. And then they could have 2 half-size legs as well, fed off exactly the same contraption. You might have a couple of little wing nuts or something. And you feed these two elements. They could go to two separate paracords. Mine went like all the way down like this, and then for 20 metres, I just had this little carabiner metal to hold it, keep it down in the wind, you see, so it didn't get twisted up. And then I made a 10-metre element as well, which is about 2.5 metres. We've got 10, 5, 2.5. You see, that's how it works. Fan dipole. So you can multi-band. Of course, you don't need 15 metres. You've already got off your 40-metre band. So very simple. There's a trick on tuning your 40 and your 15. You remember I said that 15 tunes a little bit higher? Well, it does on a vertical and a dipole, actually. And I won't get into a wormhole on this, but effectively, if it's a 10-metre element you're building, or if you make it a metre longer but fold it back 2, so you're going all the way up and then back down 2 metres, you'll find you'll still get a perfect tune on a 40-metre band, but magically, which is a new word I've just invented, what will happen is the 21 megahertz band will come down to about 21 and a bit. Very nice, 21.8, 21.9. 1.9 metres I used. And that'll work on a fan dipole as well as a straight vertical. And that's how you multi-band a fan dipole. And a vertical is exactly the same as your fan dipole. You just put multiple elements up a fiberglass pole or on a little pulley, you know, on... sorry, I thought I saw a spider up there. It is. It's very small. Which is just as well, because if it was any bigger, I'd have to leave. So you could put 3 elements on a, you know, up your apple tree. 1 for 40, 1 for 20, 1 for 10, you see. And of course, you'd automatically get 15 as well. And all of a sudden, you've built yourself, again, off exactly the same feed point. So it all comes together down to the bottom. And there's your multiple fan vertical, if you like. I'll tell you the history of how that came into my mind later on, if you like. And we've done the loop. So, yeah, I'll tell you a little bit about, I can normally remember presentations because I design them on the day I'm doing them. So I've been moving a ton of stock from my old factory to my new factory today. And as I'm driving along, I'm designing this. I've already gone off script 2 or 3 times, but you won't know that, will you? There's James smiling. It's nice to get a bit of feedback there, look. Where was I going with this then? So I'll just keep drinking, keep the gin levels down. Mm-hmm. So I was on holiday and I had this fiberglass pole. I had a 40. I loved 40 meters. We were down by the sea, and at midnight I would start in the. It was August actually, so it'd been dark maybe 2 hours. So Pennsylvania, Newfoundland was twilight. It still wasn't dark, but it used to start about midnight on 40 meters. A few radials out on the ground, fiberglass pole with a little homebrew contraption at the bottom, so I had the vertical and the radials. And I did that 2 or 3 nights. One night, I made 500 DX contacts. I had this just endless pile up to the US. It was tremendous. And many operators told me it's the first time they'd crossed the pond on 40. So that was nice. I was down by the beach, though. And if you tune around late at night on 40 meters, you don't find many Brits on there because they're all asleep trying to get up tomorrow for work, you know. Of course, I'm on every night. And it just occurred to me that why couldn't I put another element up there, up the other side of the pole? So I had 40 there, and could I try 20? And I did, but the separation was maybe 1 inch, 25 centimeters. And I didn't get a very good tune, and I abandoned that. I was that close to inventing my DX commander at that point. But what I've discovered that on the higher frequencies, I could do 20, 15 and 10 quite close together. So then I'm thinking, I probably needed more separation because it was 40 and 20. If 20 and 10 are working that close together, 40 and 20 will need to be twice as far apart. So I made one, you know, I just bit of scrap wood off the beach, and I just forced them apart, bit of tape, that sort of thing. I ended up, I got the pictures somewhere. In fact, I did a live stream once with all this on it, and that's how I came up with the concept of the DX Commander Vertical, which is just a fiberglass pole, few elements, and I have laser cut and water jet cut parts to make it all nice and make it a nice little kit for people to make, you see. Yeah. So how are we doing, Chris? Shall we pause there for questions?
Yeah, we can see if there's any questions right now. Does anybody have any questions for Callum?
I've got the chat going here. Shall we have a look at that? What does that say?
Yeah, you can drop your question in the chat if you'd like. Or...
I'll put that down on my right-hand side. No, I think they're just chilling and having a good time.
All right. Well, I know I enjoy my Commander, so...
Oh, Chris, I'm ever so sorry, mate. There's a question. I forgot you even a customer, Chris. Amazing. Funnily enough, today, I'll cover the bands in a minute, but today the security guard at Holly Farm came to see me, and he's a new subscriber to the channel, and he's just bought himself the RSGB Foundation book. He was a CBer, it turns out, in the 80s. And I think he found, because I moved into Holly Farm, my new factory, and as a security guard, he must have Googled me or something, come across the channel and gone, oh my God, HAMRadio stuff. I'm interested in that. And he's bought the book. So another few months, and we might have another HAMRadio guy on the channel. So how many bands? That was an interesting one because, you see, I talked about octaves early on and how most of the bands are harmonically related. Well, lucky for me, and for fan dipoles and fan verticals, if that's what you want to call them, is they're not purely harmonically related. Otherwise, it would actually cock us up. So the first DX Commander I made had 6 elements, and it did 40, 30, 20, 17. I can't do that, 17. It did 15 for free, you see, off the 40. And then we got 12 and 10. It turns out we get a 1 1/4 wave on 6. And then Steve from Temporarily Offline it was his best antenna. He did nine bands on he was opening repeaters on 2 meters. Amazing, isn't it? Because of the harmonics, you see. So the 6 and the 2, we just get them for free, and 15. Now, I'm a bit of an SSB man more than a digital man, so what I did, and what I say to customers, you could take either the 12 or the 30 off. I mean, who uses 12? Maybe there's some DXs that were desperate for a contact on 12, I don't know, but I have had one contact on 12, just to make sure the rig works, You could take either 30 or the 12 off and run 80 as an inverted L. So we go up. That's quite interesting, actually. The DX Commander, a regular classic pole, is 10 meters. It's not. It's a bit less, about 9.3 meters long or something. You go up to the 7 meter point, or 6.8. There's a little bit of plastic I have made. It's called ultra high molecular weight polyethylene, UHMWPE. It's very inert to RF. I suggested to customers they go up there with a little bit of shock cord, just at the contraption there, and go off, you see, as an inverted L. Now, I never thought an inverted L would work very well, to be honest. And the only reason I put it up was just to prove to everybody, it gives them another band, gives them 80. I was amazed how well inverted L works. I thought it would be neither very good at DX or local, if you know what I mean. It's quite good at both. It's very good at both. Quite amazing. So there was a fella called Steve KG1. You might know him. He's on the YouTube. He does quite a lot of live streams. I bumped into him one night on, I think we did 80, and I was using an inverted L with 35 small radials in actually 180-degree arc. Inverted L, across the Atlantic on SSB. Did quite a few contacts on 80 actually with that. So there we are. Now the problem comes with when you start doing 80 is that when you do the maths, it can get really close, depending on where you tune your 80, to the 30 meter band, 10 megahertz, and also the 17 meters. Because if you start multiplying, 3.6 by 3, you end up with it's about 10 and a half, nearly 11, to be honest. But depending on where you tune your 80 meter element, you go bang right in the middle of the 30 meter band. So running 30 and 80 can be an issue. But if you tune it for the 75 meter band in the US, up above 3.8, it'll miss 30 meters, you see. And then you can have that as a dedicated element. Otherwise, you'll find that the 3/4 wave will always take priority because it's a slightly better match to 50 ohms. But that's the problem if somebody ever... I'll tell you a story about 160, but somebody goes, could I run 160 meters on this? Well, if you're going to go up, let's say 5 meters, you're going to have now about 35 meters of wire. And it doesn't matter how light the wire is. It's either a lot of wind loading or it's a lot of weight because you actually measure out 35 meters. And it's not just the weight of the wire. Is you want to start tensioning it, don't you? That's a lot of pounds pulling the other way, you see. I'll just give you a demonstration of how big 160 is. And some of you, if you've ever put up a wire dipole for 160, you'll know, is that we have once a year, I think it's November, December, we have something called Club Calls. It's a little contest that the RSGP run. And it gets everybody on 160. And my club, to be really efficient, you need 4 quite good stations because the top 4 go into the score. I think we came 3rd or 2nd or something at the end of all this. So it was worth it. But my backyard, my garden, it's far too small for 160. So what we did is I got my big hydraulic generating tower thing, which goes up about 10 meters. And then I put a fiberglass sailboard windsurfing mast on top of that to give us another. So 8, 9, 10, 12, 40. So I had about 45 feet. And I thought, this will be easy. What we'll do is I'll run a coax-fed dipole for 160. There should be enough bandwidth. I'll probably get 100 kilohertz off it. So in the workshop, and I had a different workshop at the time, with a tape measure, I did 2 40-meter legs, right? And then connected at the end of them another 2 40 meters, not 240, 2 times 40 meters of like paracord or something. Because, I calculated, you can't just come straight down to the ground. You need a bit of paracord to bring it out, get this inverted V going. But if you think about this, from the feed point here, you've got 80 meters one way and 80 meters the other. So 3 8 24. So it's about 265 feet that way and 265 feet that way. So when we did the tune, it was far too low. It was tuning it like at 1.6 or 1.65 or something ridiculous. I needed to shorten it. And by the way, this is when I discovered that if you just fold back insulated wire on itself, it does not take off. I wanted to shorten it by 3 meters, so I thought instead of cutting it, I'll just fold it back 3. But actually, it was only taking off 1. Anyway, I had to make adjustments something like 3 times. So we're not far from the feed point. I've got to go 265 feet that way, make the adjustment. Then I've got to run 265 feet this way, and then another 265 feet to get to the next guy point that I'd shoved in the ground, you see. But the reason I'm telling you this story, I did a lot of miles that night, and it was dark. The tension required to pull this thing, not even straight, just to get some of the droop. There's some maths. Google it. It's on the internet. It's a lot of force. So how many bands are on the DX Commander? 80 up to 2, and you either miss 30 or 12 out if you're doing that, or 40 up to 2. Again, there's no traps, there's nothing. It's just bits of wire, effectively. you know, I like to simplify things. There's a number of homebrew antennas that people have created, if you like, and written instruction manuals, detailed instruction manuals that goes to, with graphs and everything, goes to 12 to 15 pages for a bit of wire, right? And I thought mine was deep. I read a book called Bad Science not so long ago, and it actually says in the book, if the more detailed baloney you write in your spec sheet, more successful the product's going to be. So with me demystifying everything, I should actually be going backwards. Maybe I should create a product and have it really complicated and write it in very, very complicated language. People go, I don't know how it works, man, but it's really good. So that was how many elements. I'll just fire up the chat again, see what else there was.
I had a question about interweaving of the harmonics between bands.
Yeah. So I wonder if I touched on that. I mean, we're lucky is that the 80-meter bands, right, sorry. Somebody called this mutual coupling. So what, you know, basically none of the other elements see the other elements. They kind of do, but they don't. And this is what, in layman's terms, what's happening. A little bit of energy leaves the element that it's got near the 50 ohm match for. Some of that energy may indeed hit another element, which will just re-radiate it. It can't absorb it. It's not a capacitor. So there may well be slight mutual coupling going on, but it works not because of mutual coupling, works despite that. It doesn't care, right? So it's a bit like if you've got I don't know, a washing line hanging next to your antenna made of wire or something. It normally won't detune anything. Because it's not the right frequency. So it just misses it. If you had a way of measuring it, you might find that there was some energy on that washing line. But in fact, it's not going anywhere. It's just being re-radiated. Now, when I look at the mathematical model, I can see this re-radiation. But the re-radiation is exactly the same cumulatively as a straight quarter wave vertical. So there we are. About 1 in 50, 1 in 100 customers that have a DX commander have a problem. And it's normally, well, there's only 2 issues that we've discovered. One is it's right next to a building, all the house wiring and all sorts of other things. But in fact, he ran a couple of tuned radials. So I said, cut one for 40, one for 80. Just lay him down the side of the building. Weirdly enough, all his problems went away. And the other guy who puts his next to like a fan dipole. So Rowley's ZL1BQD, he discovered this. He built his right next to, with a few feet away from a fan dipole. Of course, all the elements are the same size and tuned for the same frequency. It might have, depending on the coax length and a few other odds and ends. But he took the fan dipole down. It all worked. But that's, we have that problem with all antennas, really, So these guys with VHF stacks where they got 6, 2, and 70 on Yagis, the spacing between can be important just to give it a bit of air to breathe, Excellent answer.
All right.
Lovely.
Well, I guess we're going to let you go, Callum. Again, thanks a lot for agreeing to do this and spending your time, and look forward to a lot of future great videos on your channel. I really enjoy those a lot.
Well, tremendous. Well, thanks, boys, and all the best. Thanks for having me, and good luck with the club. All right.
Thank you very much.
Bye-bye now.
We'll see you later, Callum.
Sure, I hit the leave button. Adios.